Good morning, good afternoon, and good evening, everyone. My name is Chadrick Baltazar, and this is my emath 3 YouTube assignment.
To have an understanding of how to use Euler's method, let's look at this example. I have chosen to draw the line for y equals x squared. We find the gradient of the line by differentiating x squared to get 2x. However, as you see from the solid line, as the value of x increases, the slope of the line becomes steeper, and hence the gradient increases. Using the general formula for Euler's method, we can find approximate values of y at the different values of x. As seen here, to find the next value of y, or y plus 1, we take the current value of y and add the product of h and function xy, where h is the step size, which is the amount that the value of x will change. Now using this formula, let's look at the top table, where we take h equals to 1. I have chosen the starting position x equals to 1, y equals to 1. To find the next approximate value of y, we take 1 and we add the product of 1 times 2 to get 3. So when the step size is 1, x equals to 2, y equals to 3. And when x equals to 3, y equals to 7, which can be seen by the blue line. If we take a small step size, as seen in the bottom table, we will yield more accurate results. So for example, to find the value of y when x equals to 2, we take the current value of y, which is 2, and we add a product of 0.5 and 3 to get 3.5, and so on for the rest of the values of x. This can be seen by the green line. As shown, the smaller step size is closer to the actual values as compared to the bigger step size.
Now let's look at the Excel to solve the given equation using Euler's method. Looking at this table, we have three columns: value of x, value of y, and function xy. I have set the initial value as x equals 0 and y equals to 1 as given by the formula equation over here. I have chosen the step size to be 0.1, so the range of values of x will go from 0 to 1 in intervals of 0.1. The formula to find the value of y is the general formula for Euler's method. So for example, to find y when x equals to 0.1, we take the initial value of y and add the product of the step size and function xy to get 1.1, and so on for the rest of the table as given. The formula to find the gradient of the slope function xy is x squared plus 1 over y as given in the question. So for example, when x equals to 0.1 and y equals to 1.1, function xy is 0.1 squared plus 1 over 1.1 to get 0.918182.
Now to solve the equation dy over dx equals to x squared plus 1 over y, we can just go through the normal procedure using first order ODE. We integrate both sides to get y squared over 2 equals to x cubed over 3 plus x plus c. Now to solve for c, we sub in the initial values of x and y to get c equals to half. And so the equation would be y squared over 2 equals to x cubed over 3 plus x plus half. Now to find the calculated value of y, we sub in x equals to 1 into the equation to get y equals to square root 11 over 3 or 1.914854 rounded to 6 decimal places. Now going through an error analysis by comparing Euler's method to the exact solution. So the margin of error is basically the magnitude of the exact value of y minus the approximate value obtained using Euler's method. And therefore we can see that the margin of error is minuscule 0.003 rounded to 3 dp. So therefore there is a little error of 0.003 when comparing Euler's method to the exact solution using the general formula. The smaller the step size, the more accurate the values obtained using Euler's method. This shows the accuracy of the solution using Euler's method when solving for more complex or even impossible differential equations, which is one of its more important uses.
Thank you so much for listening and have a nice day.